In this video, I'm going to show two examples of how to write an equation of a line with application. So I just wanted to share just some sort of standard ways that equations show up. First of all, so this chart might be helpful. All right, I'll just go through this quickly. In this first one, we have an example where it's 45 degrees and the temperature is dropping. And so in this case, you can see that we have a rate. We've got a rate here and an initial temperature. So that is when you can just write an equation with y equals mx plus b. The rate of change is the slope, that's the m, the coefficient of x, and then the initial value is your b. All right, and then you can also have ones where they're more in what's called standard form, where you have the x's and the y's both on one side of the equation, and those show up when you have two rates. So for example, you might have a situation where students pay a certain amount to attend a performance and adults pay a different amount, but that's kind of a rate per each of those types, right? Or there's a rate for students, a rate for adults. So this is an example, and let's say that you wanted to make $250 total. You could write this $5 for every student, $10 for every adult. Altogether, we make $250. All right, and then just two special cases. The horizontal line would be y equals 45. And in that example, you might have something like it's 45 degrees and the temperature is not changing at all. So here it would be there's no rate of change. The initial value is 45, so that slope is 0. And then the vertical line, those are set up where it's x equals some number. Like for example, let's say my watch broke at 3, time's not changing no matter what temperature it is outside. So that would be x equals 3. All right, and then just one other quick note is that if you have the same slopes, then you've got yourself parallel lines. All right, so let's go ahead and get started. All right, in this example, you are planning on buying or building a house, and so there's going to be a flat fee of $5,000 for the plans from the architect. And then we're going to have a cost for the home by the square footage. So in this one, you can see that we have an initial value. All right, that's the $5,000 that we're paying the architect for the house. Okay, so in this first question, what is the vertical intercept? That's just another way of saying y-intercept of the line containing these points. Explain how you determine the intercept. All right, so the intercept, the initial cost is 5,000. So the initial is the initial value. It's the cost, the output, when the square footage, the input, is 0. Great. All right, so now we're supposed to find the slope and explain what it means. Okay, so here we go. We've got this data point. When the square footage is 0, our output, our cost, is 5,000. And now if we build a 3,000 square foot home, that's our input, then the output, that cost, would be 38,000 or 380,000. All right, so here we go. Slope, we find the difference in y's divided by difference in x's. So we've got 380,000 minus 5,000 all over 3,000 minus 0. So that gives us 275,000 all over 3,000, which is 125. Okay, and what does that actually mean? So that is $125 per square foot. And to figure out the units there, you can just, so the numerator is 275, the units there are dollars, okay? And then the denominator is, the units there are square feet. And then that means that the cost for the house is increasing at a rate of $125 per square foot. Okay, so now we have our slope and we have our initial value, so we can write an equation. Y equals the slope, which is 125, times the input, which is the square footage, plus the initial value, 5,000, just for the plans for the house from the architect. All right, there we go. So now we're supposed to determine the cost of a 2,500 square foot home. Okay, 2,500 square feet. That is input, right? Because in is going feet. Okay, so we're going to plug that into our x value, 2,500, and then plus 5,000 for the plans. And so let's see what we get. We've got 125 times 2,500. That would be 312,500 plus 5,000. So that gives us a grand total of 317,500. And again, like I said, they are certainly not living in Hawaii. All right, let's try this next one. I don't know if you've ever wondered what the relationship is between a size of a foot and the shoe size. So here's a problem that will help us figure that out. All right, so let's say that a child's foot is 7.75 inches long and they wear size 13. And then another child has a foot size that is 5.75 inches long and they wear size 7. Okay, so our two ordered pairs, we can do this as input is length of foot and output is shoe size. So we'd have 7.75 and 13 as our first point, and then 5.75 and 7 as our shoe size. Okay, so slope, we have 2 points, x and y for the first one, x and y for the second point. Okay, so we get 7 minus 13 all over 5.75 minus 7.75, which gives us negative 6 over negative 2, so that is 3. And now we're going to write a linear equation. It doesn't matter which point we use. I'm just going to go ahead and use this one because my numbers are a tiny bit smaller. Okay, so m is 3, x I'm going to use is 5.75, and y is 7. Okay, so I'm going to plug those numbers into y equals mx plus b, and then solve for b. Okay, so 7 equals 5.75 times x, which is 3, plus b. And then multiplying 3 times 5.75, we get 17.25, and then we can subtract that from both sides. And we get negative 10.25 for b. Great, and now we can write an equation. So y equals 3x minus 10.25. Okay, there we go. And now you can figure out any shoe size you want just based on the length of your kid's foot. Okay, so if you've got a foot that is 7.25 inches long, this is in kid sizes, so we'll find their shoe size. Okay, so input is 7.25, and we'll plug that in for our x. And we get 3 times 7.25, that is 21.75 minus the 10.25, and so this gives us 11.5. And that is done.